What's up, guys? Back again with another NeetCode slash LeetCode coding session. I was not able to upload a video yesterday because, frankly, I got carried away with the Portugal match yesterday, and I was not able to make a video. It was very late at night, so I thought, why not we put more effort into today's video? Do more questions. I'm just tired, to be honest. But those are just excuses. So we just gotta get the work done, right? And so I'm thinking of again, revisit linked list cycle detection, merge sorted linked list, and reorder list. So the first thing I wanna solve again today is the merge to linked list question, because I was not able to figure that one out. Kinda I was able to figure that out, but kinda not as well. So I think I have the question solved over here as well. Merge to linked list. So let's try to solve this. So we have two linked lists, so to speak, and they both are sorted, right? And we wanna essentially just combine these both to make a new list, right? So the idea behind this is we will have a dummy, which will just be a list node, and we'll have a tail, which will also point to dummy. The idea behind this is we will have a node which is dummy, right? This will essentially just start off our sorted linked list. The way we do this is to avoid the edge cases of a empty list. So this just makes sure we're not going into that. And the idea is we just want to compare the starting, right? So for that sense, if you want to compare both of them, that means while actually just to um, right, so when we are comparing both of them, that means both of them are not null, then only we can compare them, right? So let's compare them. The first thing is if L1.valve is less than L2.valve, right? And the else case would be L1.valve greater than equal to L2.valve, right? And so that will be our else case. So our first case is L1.valve is less than that. So for what we will do is we will pretty much say, okay, that makes sense. So so we will say tail dot next is equal to L1, and L1 is equal to L1 dot next, so to speak. And then we will do tail dot next is equal to L2, L2 is equal to L2 dot next, and then at each iteration we will know okay there will be another tail, so we will say tail is equal to tail dot next. Now the thing is, right, now we can have essentially two cases. The two cases is both the linked lists are of equal length. If that is the case, when we will be done by this, right, our both L1 and L2 will be equal to none, and our actual will contain all of the lists that we need, right? But there could also be the case that both are not equal, right? If both are not equal, then there are two cases. That means this one is shorter, this one is bara, or this one is bara and this one is shorter. Regardless, this will dictate how long the loop will go, and then remaining after here, this loop will keep on going, right? And so the way we can do this, if we can say if L1 then we do something, and if L2 then we do something, right? So if L1 is not none, that means this was the limiting factor, L2 was the limiting factor, and by that measure, if you see, if this is the if L this is the limiting case, we'll see, right? If we do L1 over here and L2 over here, we will essentially what we are doing is हम लोग for example let's say ये 1 2 3 and this is 4 5 so to speak. Doesn't really matter what the numbers are. What it means is, okay, let's say it keeps on comparing the both of them. This goes ahead over here, this goes ahead over here, and this goes over here, and this reaches none. So now our L1 is over here, right? And so the way we can fix this is we can essentially just say tail dot next is equal to L1, and over here we can say tail dot next is equal to L2 if, right? either one of them will be null, and then I can return w dot next, and if I run this, right, so this works great. And so the idea behind this is, after this loop has ran, what could happen is either one of L1 and L2 is none. If that is the case, we could simply just attach whatever node is there on the tail, the next to be remaining of L1, and we know ki L1 ka last wala will already have a none, so that will terminate without us telling it explicitly to terminate. Same for L2, either one of them will happen, right? So if we'll just, I mean, also to be honest, we can do this as else, but I'm just writing for readability. Right, so this returns our dummy dot text, and I think the time constraint for this is, I mean, to be honest, this is no time constraint. The time constraint is over here. So you could say it's O of n plus 1, sure, but yeah, that is pretty much the way we'll solve this, right? And yeah, that was our first question. That was interesting, so to speak. Let me just see if I understood that. Yeah. Okay, yeah, makes sense. Okay, tick. Great. Okay, cool. Yeah, this was again the same exercise, not much, right? This will work, right? Some of this also work great. um then we have remove nth node from this to मैं कर चुका हूँ. Reorder list, linked list cycle detection was quite easy, right? Not much. Linked list cycle detection was the very easy question. The way we detect the cycle is we start off our linked list. जैसे हम लोग का linked list है, right? So we start off by both slow and fast, like slow and fast over here, right? I think I will just not link list cycle. um yeah, so essentially what we'll do is we will start off, so essentially kya hai, we'll start off with, also the thing is the node length of list is 0 to that, so we'll start off by our fast pointer by over here. We'll set off our s by 1, but our head will be dashed by 2, our fast will be 2, and at every increment we'll see if fast is equal to s, and we'll check this. Essentially that's the way. So let me just write the code. Weird. Let me just write the code, and the code is somewhat like, we'll say slow and fast is equal to head. Now while fast and fast dot next, let's take care of all the edge cases that we might have. So slow slow comma fast is equal to head, right? So we'll say fast is equal to fast dot next, and we'll say slow is equal to slow dot next. um, if sorry, my bad, if slow is equal to fast, then we will, I guess, return true, else we will just return false. So that is essentially the code of this, and what this code is doing is it first offset those values and then checks if they are equal to. By that means it will always return true, right? Because initially they're both pointing right, so they'll both be equal. You have to first offset the value and check if they're equal or not, so to speak, right? So that is one way. um, Great. And then we have merge k sorted, like, I mean not merge k, a reorder list, right? Which is another interesting question. The way we do this is first we find the middlemost value. And so how do we find the middlemost value? We will have another and slow and fast pointer. Firstly, our slow will be over here and our fast will be over here. Our fast will move two places and our slow will move one place. The place where slow stops, that's our middlemost value. Right now, knowing that the constraint that we'll have at least one node, what we can say is slow is equal to head and fast is equal to head dot next. Then we can say while fast and fast dot next, making sure that fast is not none or not, right? So we're making sure that fast is not none and fast dot next is not none, because that it has to jump over it. What we can say is equal to fast dot next, and slow is equal to slow dot next. The moment this stops, slow will be pointing to the middlemost node, right? And right? Pretty much slow will be pointing to the next node, and we can say second is equal to slow dot next, and we can say slow dot next is equal to none, right? So slow will be pointing to the middlemost, so we essentially say second is equal to slow dot next, slow is equal to it. That's essentially the code. Slow is equal to it, while fast and fast dot next, we just increment them, and slow dot next, and then we'll essentially reverse second linked list. We'll do two is equal to none, and we'll say current is equal to second. I mean, now while current, so I say while current is not none, we will say that temp is equal to current dot next. Current dot next is equal to previous. Now previous is equal to current, and current is equal to temp, right? And after this is done, we can say second is equal to previous. Let's read this. So previous is equal to none, so temp is equal to current dot next. As you can see, current dot next is equal to previous, previous is equal to current, and then current is equal to temp, and then we do second is equal to prev, and we say head is equal, well, first is equal to head. Now we know that either the both half will be equal length if it's even. If it's odd, that means our first will be bigger, right? So the limiting factor will either be second or will be second, right? So what we can say is while second is not none, we can say tmp1 is equal to first dot next, right? And we can say tmp2 is equal to second dot next, right? So we have them saved. Now I can say first dot next is equal to second, and second is equal to tmp2, right? That's our change of the loop that we do. Then I can say first is equal to tmp1 and second is equal to tmp2, and that's what you got to do, because last में क्या होगा कि ये यहाँ, and if this is going to terminate, then that is already going to terminate there. So we have tmp1 first dot next, tmp2 first dot next is equal to second, second dot next is equal to tmp1, first is equal to tmp1, and that is what we have to do essentially for this code to run. I think I already, like, I have solved this previously, so it's kind of like revisiting in my mind. Maybe that's the reason why. But yeah, threesome, again, the logic behind threesome is quite funny. It's quite finky, so to speak. Like, I don't think if I, let's see if I can recall it, so to speak. Two pointers, right? Yeah, let's go. So yeah, so the thing behind this is, we will first thing we'll do num set is equal to set dot nums to avoid duplicate. And I think the logic behind this, actually not set, nums ordered, right? So we'll say ordered sorted nums is equal to nums dot sort. Actually, nums to sort, yeah, so that original. Okay, so the reason why we do sort is because we want to avoid duplicate, and the way we can avoid duplicate is, let's say if we have -3 -3 1 2, if we run this, obviously the first can't have duplicate. If we run this and we see the previous wala is the same value, that means this is a duplicate essentially. And the way we run this, so to speak, right? So we see something like for I in range of length of nums, right? Now we say if, with the only way we check for this is if I is greater than or equal to 1, right? If I is greater than or equal to 1, and so if I is greater than or equal to 1, right, that is the one condition. And if it's previous, and if nums I minus 1 is equal to nums I, then if I is greater than or equal to 1 and its nums I minus 1 is equal to nums, then this is essentially just continuing that, and we don't really want this. So we will say continue, and we don't really want to work with that, right? That's not something we want to work with. So that if I is equal to 1, greater than equal to 1, and it's equal to its previous element, then this is a duplicate, right? We don't want to work with this. So for this, now we'll do L is equal to um, I plus 1, and R is equal to length of nums minus 1. So this will always be at the end, so to speak, right? They'll always be over here. So L will be I plus 1, and yeah, so while right? Because while length is less than r, we know r will be a boundary, r उससे आगे जा ही नहीं सकता, right? So while length is this to r, if we, now this is pretty much like two sum sorted. What we will do is we'll say 3 sum, which is equal to it's equal to this array nums I plus nums L plus nums R. Now if now this is the constant, this will to change. So if 3 sum is greater than 0, elif if 3 sum is less than 0, else तो that is equal case ही है, right? So if 3 sum is greater than 0, that means we want to like decrease the value, right? Because it's greater than 0, we want to like make sure it's less, so we can do r minus 1, right? If it's less than 0, they want to increase it, so we do l plus 1. If it's equal to, then that's great, right? That is what we want precisely. So we can say result is equal to an empty array, and that means this is equal, so we can say result dot append, and I have to append the numbers. Yeah, so I'll just append the numbers, and we know by default that this will be sorted because I L R ऐसे आता है, so nums L and nums R, right? And now it's interesting. Now what I gotta do is what I need to do is, you can do many ways, but the first thing is, okay, now I want to change the L, right? And while L is less than R, right, while obviously L is less than R, and right, nums L is equal to nums L minus 1. So while this is true, I would want to do L plus 1. What this says essentially is making sure that L still remains behind R, and that nums of L is, so while that is true, while it's behind the true, and while this is also true, that is equal to that, then only we'll do increment ahead, right? And so this will essentially increment this ahead, and then I could just return the rest, as I know that will be perfect. Run this. Okay, something wrong happened. Great. Okay, something went wrong. Let's see what happened. So we say for I in range, length of nums, great, nums dot sort result. So for if I is greater than, let's see, we'll sort this. We'll sort this. If we sort this, what we'll see? -1, -1, 0, 1. Actually, to be honest, we'll see -4, -1, -1, 0, 1, 2. Now, while I is greater than equal to 0, इसका I, क्या I false, so this won't run. So we say L is equal to I plus 1 and R is equal to length of num minus 1. So while L is less than R, right, we'll say 3 sum is equal to nums I plus nums L plus nums R. If 3 sum is greater than 0, if it's greater than 0, then means we have to decrement it. So we'll do R minus 1. If 3 sum is less than 0, then we want to increase it. Yes. If it's equal, then we do nums I, nums L, nums R, and then we change L. So yeah, so if we have that, which means like so to speak, if we have something like -4, -1, -1, -4, -1, -1, 0, 1, 2, right? If we have this, and if we start from here, this is 0, 1, 2, right? Right, so is it, no, so right, we start from, this is our L, this is our R, right? Is the indentation is the fault? Is the indentation the fault? No, indentation is perfect, so to speak. Yeah, so we pretty much do that, and while L is less than R, sure. 3 sum, so we essentially do 3 sum, which is -4, -1, 2. So this is -5 plus 2, which is again -3, which is not exactly what we wanted. So because -4 minus, so -3, so this is -3, so -3 is less than 0, right? So we will pretty much increment it over here, right? Okay, ठीक है, we incremented over here. um Again we do -4 -1, same result. Again, -4 plus -1 is -5, -5 plus 2 is -3, -3 is less than 0, then we come push our L over here and we say -4 plus 2 will is equal to -2, that is still less. And so we will essentially just, what is the issue that we get? Oh, it's the wrong, okay, then we put L over here. Yeah, so over here what we do is we find out key. Okay, so this is -4 plus 1 plus 2, this is still -1 less than that. And so यहाँ पे we then come to L and R, so that equals that pretty much stops. Great. Then we come to over here, so this ये वाला loop खत्म हो गया. Now क्या I greater than equal to 1 है? Yes. And क्या nums I -1 equal to है nums I के? क्या -4 -1 के बराबर है? नहीं. So again we take our L over here, we take our R over here, and then we start calculating. While L is less than R, yes sir, nums I plus nums L plus nums R. Right, so over here we have -1 -1 2 -2 plus 2, which is equal to 0. Right, so okay, so this is, why is it not giving it? I'm so dumb. Yeah, I was so dumb. I'm so dumb. Indentation, right? It gets you. Yeah, and so that works. And so obviously, like, this gives us 0, and we know that L ka value kuch hai. So I could just pretty much say, okay, now L is this. While L is less than R, and so it's equal to it, but ye not equal hai, so this won't even run. And this will again check, right? So cool, that works. That works great. Same ye code hai. Let's close that. Cool. Okay. It's good. I mean, yeah. That's good, yeah, to be honest. Like, it's great. I think we should do merge k sorted linked lists. I don't know how we'll get this, but I think we gotta try, right? I mean, we know how to find the middlemost value in a linked list. We know how to reverse a linked list, right? And I actually just try to do this question again one more time. I think I have some I have some better solution than what I. So we have to reverse a linked list. I never did this, by the way, crazy. What could be the number of nodes in the value? Okay, so cool. That makes sense. Okay, so we can say previous is equal to none, and we can say current is equal to head. Sorry. Right. Right. And what, iteratively or recursively? I know how to solve it recursively. Recursively, it's recursively interesting. You could do it recursively, but yeah, this is a good follow. It's a good follow up. Yeah, so we do pretty much that. And we say, okay, while current is not none, obviously we do certain things. Right, what do we do? The first thing is we say, okay, well, we have a temp variable which says current dot next. We'll say current dot next is equal to previous is equal to current dot next, and then we'll say current is equal to temp, right? And what happens is, we can pretty much say head is equal to previous return head, because return, that will contain the start of the linked list. It's wrong, crazy. Why so? This is the input. Okay, let's see. Issue क्या हो रहा है इधर? Previous is equal to none, current is equal to head. Okay. While, okay, while current is not none, right? So we have, let's keep a very simple example. ये वाला example रखते हैं, none, right? So right, cool, makes sense. This is our head essentially, guys. So we say, okay, this is our temp, by the way, right? um, Temp is equal to, right? So current dot next is equal to previous, so इसका previous अब हो गया none, and ये अब आपका previous हो गया, and then current is equal to temp. So temp यहाँ पे आए, this ये becomes our temp, and current dot next becomes whatever we store. मैं समझ गया गलती क्या है मेरी. Yeah, so current dot next is equal to previous. मैं समझ गया गलती क्या है मेरी. Previous is actually equal to current itself. My bad. Current previous is equal to current itself. My bad, chat. My bad. My bad. Yeah, my bad. That's my bad. Right. So that is one of the reverse linked list questions that we did. A linked list can be solved iteratively. So this is iterative solution and or recursively. Could you implement both? That's a good question. So I think about recursion. I think the best thing about recursion is you need to think about it like you need to think about it in a sense ki what the hell? Sorry, what the hell did I just saw? I think about recursion. Think about base cases, right? So if our head is equal to none, well that's good because we can just return none, right? And that's one of the best. That's one of the base case that I can think of in my head at the moment. I do not like recursion. If you don't know, now you know, right? I think they have to give more than that. Okay, I'm gonna leave the recursion part for now. Right now, I'm just gonna leave the recursion part for now. Because I wanna do the hard. I think the only way you get good at this is by repetition. So don't get into the habit of thinking that you're God gifted. Like I mean, if you are, then that's good. But don't be in that habit because then if you don't solve something, you'll be like, oh well, I'm dumb, or you'll say some negative things to yourself, which is not productive by any means. So just don't do that. Cool. Let's put a 30 minutes timer, I guess. I think 35 minutes would be good. So let's start. Unless I give up before that. So cool. You are given an array of k linked list lists. Each linked list sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Okay, so we are given these lists, and it pretty much these are like bunch of linked lists. So you can think of them like if I take this, right, you can think of them visually as okay. So we have one, none, and this is our sum. I think we'll have uh, so we have a list of lists. So we'll have a list which in itself I'm assuming that contains the head of the pointers. Anyhow, that is, let's say this is list one. Now this is like linked list one. We have a linked list two, which is also one, none. Linked list three, which will be two, six, and none. Great. Right. And I'm assuming this means this will be pointing to the head. Great. Right. The linked lists are okay. Merge linked lists are this. Right, so it will be something like for LL in, so that will be all the LL, so to speak, right? That this will be all our so we're pretty much looping. Okay, cool, and then we have to merge it. So k is equal to list dot length. Okay, so we can have up to 0 linked lists to, I think the very first thing we can do is if length of list is equal, I don't know how it works though, right? Because this is 0, right? So we can essentially just return none, right? And other cases we will figure out later because that makes sense, right? If we don't have link, because I know for a fact if I do Python compiler, something like that, right? If I do something like pretty much if I do something like list is equal to this, and if I print length of list, I'll get 0, right? But if I do something like this, well, technically it's 1, right? Technically it's 1, so that wouldn't really work, so to speak. This will pass one test case, maybe the one edge case. They had an edge case. Yeah, that else works. Anyhow, Right, so then we have this, and then the individual linked list in the list of all the linked lists can be of this length, and I'm assuming this means the actual value may range between this, the sum of, yeah, of course, and then let's assume we have 5,000 of them, so 5,000 into. Cool. Okay, so I think let's just go to the blackboard and think about this like instead of that. Okay, so let's imagine if I have three linked lists. So I think I'll just have a dummy node over here. So we'll have a dummy. Same, I think dummy really helps us um, to think about this question in a very easy way. I think my logic would be, and this could be very bad, is we start iterating like one by one, obviously. I mean, I would love to have like, okay, so, okay, let's keep it very simple. Let's say if I have all of these variables, which I don't know how will I get them, right, so to speak, like, because I've just given like them. Hmm. How will I do that? Like, that's interesting now. Okay, let's just imagine if I have it. If I have L1, the only reason why I'm able to compare the three if all of them are not none, so to speak. So I'll compare them, right? I'll compare. How will I do this if I was a human? So one, well, doesn't really matter. I can keep one over here, right, and move to this, and then compare these four, right? Whichever the one is the chota, I will just do that, right? Then compare this, um, compare this, and then compare the sorry, like this would go ahead. Then compare all of them, right? I'm just assuming like that will be that, and let's say I'll put it over here. Compare again, and this comes none. So this comes none. So we stop using this at all. Then we do 5 and 6. Obviously, the 5 is the shortest. Then we come over here. Well, as soon as it nuns, then we don't really do anything, and then 6. For comparison, the minimum elements we need is 2. Right? Having 3 is not bad, but it's not required. The question is, right? The question is, because I have LL in list, right? So now I'm accessing all the, so to speak, the headers, but it's iteratively. Um, hmm. So if I could do a while loop, so to speak. Hmm. So we might have a while loop, but that iterative, I don't know how to. Like I'm kind of like blind. So for LL in list, what does that do? For LN in, let me just write it over here as well. To be honest, like we have these bunch of these like 1, 4, 5, right? This is just bunch of them that will be accessible. Actually, not even this. We'll just have like, I mean, not to like figuratively, but we'll just have these stuff just one by one to us. That's not helpful, right? Because we would want, what we would want is that um what we would want is to have access to them in the same time as the way we did it in the merge sorted linked list, so that we can talk to them like that. How can I do it like that? This is for LL in list, obviously. I'll have one-to-one access, which is not that great because if I come here, well then I have to access this. And if there's a way I could put this in some data structure where I could just have them later and then refer to them, but then I don't know how many numbers of them would be there, right? So that's kind of like, it's kind of like fucked up. How can I do this? Like I'm just the thing I'm confused in is How do I access them? And I know for a fact key if I do like because LL itself is the like this itself is the head node, right? Because we'll be accessing the head node. Um, no, this is not going to solve anything, right? This is just not going to solve anything. This is going to be what I'm trying to do is like if let's say we have something like null example, so to speak, um, like we have like null examples, like over here we have null. So if not null, right? If length is there, but not null, so to speak. So not null list NLLL, something like that. I mean, that's so bad name, but um, right. So if LL is not none, we'll just append it to this. So now that's this is basic optimization. So so now we have not null linked list in order. Now what? Let's assume again. Let's say 145, 134, and 2 comma 6. So now we have all of them. Again, the question is, wow, that's a great optimization, but then how do I interact with them? You could think of a while loop. I don't know how a while loop might help in this case, but okay, let's assume we have like bunch of them in a list, right? So they're bunch in a list. So we could say, okay, well, I mean, we could say while I is less than length of not null linked list. If I do something like NNLL, well, that is head of like that is essentially head of ith index. Um, hmm. I um hmm. What that hits me is we know ki nel nn ll 0 1 like if we have k elements, that is if we have like 2, this will go up to 0 to k minus 1, so to speak. So if you have k3, it will be 0 1 2. That's many how many we'll have. Or what if we do something like, okay, let's merge these two linked lists together, right? And then this will have a merge linked list. And then we merge this linked list. Oof, that might work, Chad. That might work. This is a bit dumb, but yeah, I think that might work. If we just like, okay, we just take two pairs of them. But oh, that's gonna be an issue. No, it's not gonna be an issue. We kind of we kind of can do it. I don't know how that's possible, But we can say, okay, we're just not gonna divide all of them, we're just gonna merge two of them, right? We'll have one unit, and then we merge the other two. So it'll be something like merge these two, then merge these two, then merge these two, and this merge these two. Then that will be done. But then that code will be quite big, right? Because that code will essentially be merged to sorted linked lists, essentially, right? It will be essentially this much lamba code. Okay, let's take this code. Let's take this code. Like, did I copy that? I did copy that. Okay. Um, um, this is, what is this called? Def. This is what def merge two lists, and def merge two lists, and this one's L1, L2, L1, L2. Obviously, this, um, I'll just copy the definition, so to speak, as well. There's nothing wrong in doing this, right, chat? Let's do something like this. Now the indentation is all kind of hellish, but I can fix that. I can fix that. This is a child's play. Okay, I can just indent this. So now, okay, let me just. So now I have a function. Actually, don't need to put this for now. Now I have, now I have a function that merges two lists for me, which is good. Which is good. Now I don't know if this is possible or not, but so not LL. For LL list, not that. Now I just gotta merge two of them together, right, so to speak. So merged, man, this is getting, this is, it's like it's so many things are coming in my mind right now. I mean, this, you don't have to worry about this, to be honest with you, right? So how do we do that? How do we say like two lists? And to be honest, if it's like one, uh come on, man, help me. If it's even, that's fine. If it's odd, then it's also fine, right? Because we can say, okay, merge this, and we get one unit, obviously. And once this is merged, we check the first merge check. Sorry, nums, it's, I think it's lists. um mm, right, so we loop only till here, right? And this, I think the, so we so this is like 0 1 2, and we'll only loop till here. So what we'll say is, we will essentially just say merged head is equal to, uh, actually, why is it taking self? I'm going to take self. And what I can say is, I can say, while I'm doing this, I can say list dot I, and I can say list I plus 1, right? And so this will essentially just merge these two together, right? um I know what, that you might be angry with this solution, right? And you have the full right to be angry with this solution. right? Um, uh, and I'm dumb. I'm dumb. Yep. So this I is gonna be on an infinite loop, so to speak. I'm so dumb, chat. Anyhow, regardless of that, it will be plus my bad. What? Um, wow, it was almost giving the right answer. What the hell? What am I doing wrong? Merged head is equal to none. I is equal to 0 while I. So if I is 0, then it will merge with list I and none, and that will just enter merged head. Merged head will be equal to, because that if it's ahead of I, that means it has already used merged. What? Wait, chat, it actually got accepted. What the hell? Right, it got accepted, but the time is horrendous. So yeah, essentially what I did was I was like, okay, fuck this. We'll just merge two lists, and we'll just okay. So this कोई के साथ नहीं होगा. This will get merged. I mean, to be honest, if that is the case, merged head will be equal to list I, right? That's like dumb. What am I doing? Right? What am I doing? And so if not, then it'll be just be that plus merge with the previous one. And yeah, I mean, wow, this kind of works. Do we need this though? Do we need this? I would say we don't. I would say we don't. And let's see if this works or not. Let's see if this works. I feel like we don't need to do that because I wouldn't run, right? And so yeah, that works. Great. Guys, I have to go eat lunch. After I eat lunch, we'll be back. We'll see the optimal solution. But stay hanging. Back after my lunch break, and yeah, I don't know. I just hope I don't feel sleepy, to be honest with you. Because if I feel sleepy, then I don't think this video will go on for long. But yeah, let's show. Cool. So what's happening over here is quite simple. What are we doing is for each loop, right? For each iteration. By the way, this itself takes O of n, right? It's scanning through it. So this takes technically O of n plus m. I would say it actually takes O of n being the shortest length among the both of the strings. But let's just assume it takes O of n, like being the shortest. So we are running this for n iterations, and for each iteration, we are running an algorithm that pretty much is running on some form of um, and the length of each list could be how much. मान के चलो n ही है मतलब roughly लेके चलो तो it's roughly O of n square or very close to O of n, maybe something like O of n m, and m is like could be very nearby n. So O of n square algorithm hai. That is why you will see in our solution also our memory usage is to chill, right? Our memory usage is chill because we are not making any the only memory we are using is this merged head that grows. You could say memory is O of n as well because the question expects you to give a new linked list, a sorted linked list from the original. So it's O of n, which is manageable. ठीक है चलता है. But our time is so bad when you see like majority लोग का time इतना कम हुआ है. मतलब there's a valid algorithm. There's an O of, let's just say O of n algorithm for this. And I mean, I wouldn't know, right? I wouldn't know. But yeah, looking at the code, um, very interesting algorithm. So we have array dot this. So for head and list, while head array dot append head dot val. Head is equal to head dot next. Oh my god, array dot sort. Oh, oh my god, chat, are you looking at this? Brother, are you looking at that? That solution is, first of all, I don't even know that's valid. I mean, oh my god, that's okay. So the way they do it is they say, that's actually kind of dangerous. For head in list, while head, and we say array dot append head dot val, and we will say head is equal to head dot next. That's actually genius. Array dot sort. So over here we'll pretty much say for head in list, while head is not null, array dot append head dot val, array is equal to this. Then we'll say array dot sort, right? So um, right. So the while we are doing this, one thing I could say that this itself, technically it's O of n. So we're doing n times, and each of them is, let's say, maximum is m. So this is O of n is to m, and then this is, well, let's, this is the length of this list. Will be, there's so many. Let's just say, yeah. So it's pretty much n. तो टोटल एलिमेंट उतना ही होगा ना, राइट? टोटल एलिमेंट उतना ही होगा log n star m. So we can take n star m as some value of x. So this is O of x, right? And this is O of x log x. Okay, okay, not bad. And then we do this, and then we do merged. Actually, no, we say something like dummy is equal to list node. That's actually kind of sassy. Okay, chat. So I I mean, I don't know whether this solution is valid also or not, but pretty much what the person does is, by the way, over here, this is also just like a it's, wow, that's crazy. So the way this person solves this is quite interesting, and it's quite something that's so simple that you wouldn't. So you say something like, let's say nums, and you say dummy is equal to list node, and you say tail is equal to dummy, right? And now what you'll do is for head in list, while head, right? We will say nums dot append head ka valve, and then we do head is equal to head dot next, right? And then we'll do nums dot sort, right? And then we will say for num in nums, we will say tail dot next is equal to list node, right? List node with num, and we'll say tail is equal to tail dot next, and then we just return dummy dot next. That's actually smart. That's genuinely smart, bro. Like, so we pretty much took our O of n square algorithm to O of n log n, and this is so simple. You don't have to deal with the pointer jadoo. Wow. Okay, chat. This, I kind of feel like I got robbed, bro. To be honest. Yeah, I mean, this kind of makes it too simple, right? To be honest, like if you just say, well, because The thing is, right, कि आपको बोला गया है कि each list itself is sorted, but you don't really care about that property. You're just saying, okay, जो भी है, put it all in an array, and also this is like the space complexity for this O of n. But that's noted, and you're making O of 2n, to speak, right? But it's still O of n. You don't actually, you just ignore that, right? I mean, if someone gives you that property, that means that they want you to use that property, right? So I guess not. It's not a solution I will definitely go by. I think I'll just see neat code solution because I guess I can't think of any at the moment. You could say so.
Hey guys, it's me, NeetCode again, solving another LeetCode problem. This time we're doing merge k-sorted linked lists. Before we've done merging two sorted linked lists, which is an easy problem. I think it was LeetCode 21. So if you haven't solved that one yet, would recommend doing so because we're basically extending that problem. That one yet? Problem. I think it was LeetCode 21. So if you haven't solved that one yet, I would recommend doing so because we're basically extending that problem. So this problem is actually easier than you might think for a LeetCode hard problem. There's some really basic ideas that we can use to solve it efficiently. So to illustrate that, I have four single.
The funny thing is, he said you need to be comfortable with min maps and all. क्या हो गया? Oh, okay, you have earned a stick repair. Oh, okay, that's crazy. Can I use it on this? Oh, okay, that's much better. Yeah. Why did I not do that day? I don't know, man. I don't know why. Because like, should I use my stick repair over here? Nah, that would be dishonesty. I can't do that. The thing is, आप पढ़ाए नहीं ना min mat ho, and this is not connected over here. So that's the reason why I didn't learn that. But anyhow,
Node linked lists, right? So each of these linked lists only has one node, right? So 5, for example. So basically, how can we merge them in an efficient way? Let me show you like the general idea. So first, we can merge these two, 5 and 7, right? So the first two nodes, when we merge them, we know that the 5 is smaller than the 7,
yeah,
so we put the 5 first. So now we have a
yeah.
partial
So
linked list. So
pretty much that was my first solution. Was like we just take the two lists and we just merge them with the before one. Um, that's Wolf square, right? You would say.
now we want to get the next value, which is 3, and we want to merge it into this linked list. Again, the 3 is smaller than the beginning of the linked list, which is the 5 over here, right? So we can just put the 3 at the beginning. And next, we only have one value left, so we want to merge this 8 into our linked list. And so what's the general idea of how to do that? Well, we're going to have to take our 8, right? Look at this 3, right? Well, it's bigger than the 3, so we're not putting it there. Is it bigger than the 5? Yep. Is it bigger than the 7? Yep. So we're going to put it at the end. So notice how we had to iterate through every single node to find where to put 8. That's kind of a problem, but we did find the output. The output is going to be the 3, 5, 7, and 8. So doing it this way is not the most efficient way to do it because notice for each node or linked list, we're going to be merging it into our current output or our current result. We're going to be merging it. That's not going to be super efficient. We have k lists, right? And the total number of nodes we have is n. So every time we're merging a list, we're going to potentially have to iterate through every single node we have so far, which could be big O of n. So the overall time complexity is going to be k times n. Now, I bet you already know where I'm going with the solution now because the picture really makes it obvious. Why would we merge it like this when by doing that, we're really repeating a lot of work. That's really not the most efficient way to do it. If you know the algorithm merge sort, you know that there's a better way to do this. So, and it's a really basic idea, right? Like, why merge it that way when we can merge these two and merge these two, eliminate a bit of that repeated work, right? And then when we have that, like the 5 and the 7, now using this, we're going to merge these two together as well. And assuming you know the algorithm to merge two sorted linked lists, we will get the standard
Merge sort on linked
expression, right?
list.
But let's analyze what exactly is going on here. When we did this first step, right, over here, when we went from 4 linked lists, right, 1, 2, 3, 4, and then we went to just 2 of them remaining, right, we did have to iterate, we did have to go through every single node. So this was a O of n operation, right? So it's still not cheap, it's O of n. But the question is, how many times do we have to do this? In this case, we only have to do it 2 times, right? So we did the same thing. We took our 2 linked lists down here and merged them into our result. And again, we had to potentially iterate through every single one of our 4 nodes, so it was an O of n operation. But basically what we're doing is we're taking our lists and dividing them by 2 every time. So how many times can we take the k lists and divide them by 2? Well, it's going to be log k. This is the part where we speed up our algorithm. It's log k. Log k is the number of times we're repeating this O of n step. So in this case, with this algorithm, the total time complexity is going to be n log k. And that's a lot better than the brute force, which was n times k, right? So this is a lot better. Okay, so now let's actually get into the code. Remember that we have to understand how to merge 2 sorted linked lists. So I'm just going to put that function here right now. So we'll have list 1 and list 2 as
Or you can define
parameters,
it
and then
outside.
we'll return the output list. I'm not even going to do this yet because we know this is not the most important part of the algorithm. That's the LeetCode easy portion. We want to do the real part of the problem, which is merging k linked lists. So the first thing I'm going to handle is the annoying edge cases where maybe...
Wait a minute, I'm just confused. Just think of something. Okay, buddy. I'm confused. Wait a minute, wait a minute. Which question?
the list is
Can this
null
thing stop? Crazy. Um, what's
or
happening?
the list is of...
Yeah, so merge two sorted lists. Cool, but the merge, yeah. Okay. Merge two sorted lists, buddy. There are two sorted lists. We're not the way we merge them is by O of n. There's no merge sort happening over here. I don't know what. I think he's confused.
length 0. In that case, we can just return an empty linked list. And now to get to the actual problem. So we're basically going to be taking pairs of linked lists and merging them each time. And we're going to keep doing this until there's only one linked list remaining, and that's going to be our output. So while the length of lists is greater than 1, we're going to keep reducing it, right? We're going to keep cutting it in half. So as we merge these lists, I'm going to put them in a new list called merged lists. So now we want to iterate through each of these lists. And each time we know we want to do pairs of linked lists, so my incrementer is going to be 2. So list 1 is just going to be at index I. Now list 2 might be out of bounds, right? Because if we have an be null, so we have to check for that. But we want to make sure. So if we'll do that, because merge will do. I helped over here where we are. I've seen people do it a different way. Until there's only one list left, and then we're gonna return that list. So list, the idea, you see, it's really not that bad. Now we've reduced. Want you to
Chad, this is my solution.
dot append. We're appending to the output, or appending to this list, and hopefully that is good enough. Okay, of course I get messed up with the typos. Merged list. I guess the confusing part was that this variable name is pretty
Chad,
similar to this function name. Probably should have done.
this was my solution. Wait a minute, I didn't even record my solution. I'm such a dick. Chad, this was my solution. This was my solution though. Initially, that's what I did. It's recorded. That's what I did, right? So I guess the way to do this would be simply as, um, what what control that? Okay, okay. What's the confusion? Ah, my bad. Because its context is not there. Um, oh, I mean, I'm also, yeah. This happens when you don't do your. This was my solution, by the way. Okay, it's not technically that, to be honest. I think I know what he's trying to do. So व्हाट ही इज डूइंग इज इनका एक इसने लिस्ट बना दिया, फिर इसका इसने लिस्ट बना दिया, फिर इन दोनों का इसने एक लिस्ट बना दिया। मैं क्या कर रहा हूँ, मैं इसका एक लिस्ट बनाया, फिर इसका बनाया, देख इसका एक लिस्ट बना, फिर ये आया, ये एक और लिस्ट, फिर ये एक और लिस्ट, फिर ये एक और लिस्ट। ये आप कब तक चलेगा, ये आपका चलेगा के तक चलेगा, एंड ये के तक चलेगा, एंड हर के बार when this is running ये लगभग मतलब दे सकते हैं n, राइट। सो दिस इज k is to n। ये बंदा क्या कर रहा है, ये बंदा बोला, दिस गाय इज सेइंग टू हेल्प विद दैट, मैं करने वाला हूँ, मैं इसको 1 डालूंगा, 2 डालूंगा, 2 3 4, मैं 2 को लूँगा, 1 बनाऊंगा, तो अगेन दिस इज गोना बी n, इसको 1 बनाऊंगा, एंड देन सो बट दिस विल कंटिन्यू टिल log k, and then he's saying, well, we can do n log k, this is much better than n k। समझ गया। समझ गया। Hmm. I. So yeah, that's very smart actually. So what he does is he says, well, merged head is equal to this. Now, while the length of list is greater than one, right? Greater than one, right? So the first thing he says for I in range of 0 to length of list 2, right? L1 is equal to list L1, and well, for me, I still do that. So if if I plus um he doesn't do that, so why should I, right? Um, if I plus 1 is greater than equal to length of list, if it's out of bounds, so to speak, we'll do this to be none, and then we will do merged head. Actually, it doesn't really matter, to be honest. Like if you're inside or outside, merged head will be what is append mm, mm, pretty much that, right? And then here's a classic stroke he does. He says, well, list is equal to merged head, and then finally returns list, pretty much outside this. Not the entire. I mean, um, I'm so confused.
differently. Okay, but it does work, so hopefully you get the general idea. It's not too bad of a problem. There are actually a lot of ways to solve it, even a heap solution. But I think kind of sticking with this is fine. But thank you so much for watching.
Cool. I think we have to practice one more time, I guess. Because I know the solution, the way it works. Instead of doing this sequentially, what we do is we essentially compare these two. Then we compare these two and we wait until we only get one. That is why you will see over in this solution, we wait till like we keep doing this until the length is equal greater than equal to 2. The moment it becomes less than that means it's 1, and we just return 0. The first, it's the head essentially, right? This code sample was horrendous. Cool. So hmm hmm yeah, the heap and all is over here, which is crazy. um wow. ठीक है guys, I'll leave it. I'll leave it till here, right? We'll leave it till here. Because I mean, I could go ahead and do binary search while I core, but like we're not trying to do quantity over quality. We're trying to get as quality as possible. Like I was able to understand how to do them. It's actually very neat optimization. Instead of doing it sequentially, we can break it down, and so we can do it n log k, which is n into log k, which is better than n dot k, obviously, because log k is very smaller than k. That's interesting, right? So yeah, it was, I mean, fun solving all of this. We're pretty much done with this level, which I'm very happy about. Sliding window, binary search, these two. Search this. I'm very interested by this question, right? Because this question is not like your normal binary search question. Because in a binary search, you know the list is sorted. Over here, technically, the list is not sorted if you were to unreverse it, obviously. But how will you unreverse it? I mean, if you know how many times it has been reversed, right? But cool, I won't do this now because I don't feel like I have the prerequisite knowledge for this. So I have to sit down and actually understand how. I mean, though everyone would like to say that they understand how binary search works, do they really?